Okay, so let's say you've come up with a brilliant idea. You've found a research topic, you've got your edge, so it's something that you've done first in the world, but is also important and interesting. You've beaten all those other tens of thousands of researchers to something. What do you do now? Well, you need to publish a paper. This is how you prove to the world that you've done the research and establish your priority. And unfortunately, this whole publish mentality has become somewhat gamed, now rather dangerous. As a researcher, you will be judged on how many papers you publish, what journals you publish them in, and how often other researchers cite these papers. So you need to publish a lot of papers. To be competitive in the job market as astronomy now, you need to publish probably 5 or 6 papers a year, probably more than that. Then the papers need to be in prestigious journals. A paper in Nature or Science counts for a lot more than a paper in the publications of the Astronomy Society of the Pacific. And this has got a longer lead term. You need to have papers other people cite. People will say how many other people used your paper, your research, and the proxy for this that people normally use is to see did other people cite your paper. So how do you publish? Well, there are going to be a certain number of journals in your field, and there'll be some sort of typically understood league table of which ones are the prestigious ones and which ones are not, and other particular rules, like some only allow for short papers as opposed to long ones, and take longer or shorter times to publish. You submit your paper, written in the journal style, and it's then refereed by between 1 and 3 typically other scientists, who will be other scientists in your field, and they're typically chosen to be knowledgeable about what you're doing, but not in your own research group or direct competitors to you. And that can be very hard as a journal editor. Trying to find people who are interested in your work and knowledgeable about it, but you're not your competitors, is almost impossible. The old joke is if you've got no conflict of interest, you've also got no interest. So very often it will be your rivals who are refereeing your paper, and that causes problems sometimes. Now this has become a bit of a treadmill. Many researchers think because they need to publish so many papers all the time, and they've all got to be influential papers in top journals, they have no time to think, no time to read, no time to plan long-term things. They've got to get the papers out this year, because their job might be at the end of this year, and if they haven't got 6 papers out, they're not going to, and 3 of them in Nature with the first author, they're going to lose the next job. So this is arguably a big problem, that large numbers of young researchers are very focused on short-term. They need to get the papers out this year, because I'm on a fixed term contract, my contract will end in 6 months' time, and if I don't get the papers out now, a paper that comes out in 2 years' time because I've done some long-term research project won't help me get my job. I'll be unemployed by the time it comes out. So because of this intense pressure, we've seen that people have these postdocs, and are typically you have to apply for your next postdoc my first postdoc was 2 years, my second one was 1.5 years, so it could be talking about that means when you start the postdoc you might be applying for the next one within a few months, or at most a year or so, and when you apply, people are going to look at your record and say, is this a productive scientist? They're going to see how many papers did they have, are they well cited? And so people game the system. One way they game it is so-called minimum publishable amount, MPA. Let's say you've done a body of research. You might publish a good paper on that body of research, but you think, what's the smallest amount of research that I can get away with publishing a paper? What will get past a journal? Maybe I can break this one big research project into 3 small ones. That way I get 3 papers. My CV will look much better. And there's certainly an awful lot of this goes on. People trying to work out the absolute minimum they can get away with to get through the refereeing process. I do a lot of refereeing for papers, and I see lots of papers along the lines of, why did they stop here? They've only done 1/3 of the research project. And the answer is probably the other 2/3 will be 2 more papers. Then there's citation rings. People will often cite each other's papers. So I'll cite your paper if you cite mine. It's never expressed as plainly as that, but it's kind of an implicit quid pro quo. That if you want to be friends with somebody, then you need to cite them, otherwise they'll be insulted. And if they think you're someone who appreciates them, they'll probably cite you back. So nothing as crude as an explicit agreement, but certainly this can mean that some quite mediocre papers can get very large numbers of citations, once again gaming the system. What's also happening increasingly is that there are predatory journals, journals where you have to pay to put your paper in them, which is actually true of many prestigious journals as well. But increasingly there are these predatory journals who exist purely to help researchers up their publication count. I probably get 4 or 5 junk emails a day from people saying, send your paper to us, we have a refereed paper that's listed in all these indexes. And this has been a big problem. There are now huge numbers of papers that no one ever reads in journals that no one's ever heard of before, but they all claim to be refereed, and depending on the exact system, you can list them on your CV, and you can have a look at really good. I've published 400 papers in the last 5 years. Sure, no one's read any of these things, except for my buddies. We all cite each other. So it's become a really somewhat corrupt system. There's a general theory in management that whenever you use a proxy to measure anything, that proxy immediately becomes meaningless because people game the system. So originally people published papers because they wanted to share their information with the world. So people thought, oh, okay, how many people read this and how much they publish is a proxy for how good they are at researching. Well, let's use it to decide whether people get jobs or promotion. But as soon as you're using it as a metric, it becomes corrupt because people then will game the system to try and publish more papers, and their preoccupation is now with get the paper out rather than I've got this really interesting thing I want to share with the world. So it's quite bad. And then publication is not enough, because we see that everybody is so busy publishing they don't have time to read papers. There's far too much putting them out, because that counts, and not enough reading of stuff. And because no one has time to read these vast numbers of papers that are always coming out, most of which contain very little useful information, you need to network. You need to actually go out there, go to conferences, give talks. This is a mistake I made. I had a lot of trouble finding a job after my first postdoc. I'd done a lot of very good research and published a lot of really good papers, but people didn't know me because they hadn't read my papers. I had to actually go around, visit places, give seminars, talk to people, build a network, and build collaborations. It's actually usually a lot of fun travelling around, talking to people about science. I mean, you're only in it because you like it, right? What could be more fun than talking astronomy to another astronomer? And often good ideas come out of these things. So you absolutely need to network, talk, communicate, and it's usually quite a good thing. Increasingly, there are also other techniques. As well as getting a formal referee publication in a journal, you can often put the same thing out in a preprint server like arXiv. And this is actually where a lot of the research works because it's much quicker, especially in fast-moving fields. And increasingly, scientists are using social media to network and collaborate amongst themselves. Another part of proceeding well in a career is getting competitive grants. Now, in most of the English-speaking countries, Australia, USA, UK, most research funding comes in a grant. What happens is that, let's say you want to do a research project. You work out how much it's going to cost. That might be we need to buy particular lab equipment. It might be we need to fly to a place to do particular observations. It might mean we need to hire 3 postdocs to analyse the data, whatever it's going to be. And then you apply to a research council. In Australia, normally the Australian Research Council, or ARC, for money. So you'll say, please give us $500,000 over 3 years and we will spend it like this. And you write an often 50-page proposal explaining what you're going to do if you get this money and why it's going to be so exciting, how you'll revolutionise science. If only you give us this pathetic $500,000, we will do all this amazing stuff. Sounds wonderful. The trouble is you need to apply for a lot of grants, many a year probably, each of which is typically a 40 or 50-page form. So most senior researchers will spend probably 30 to 40 or maybe even a larger percent of their time applying for grants rather than doing research. Now there is some good thinking involved in writing a grant. It forces you to think about your research program. What is your strategic edge? What's the technology like? What have other people done? But also there's a lot of mindless filling in budget forms, and if you get the wrong thing in the wrong form, you can get rejected irrespective of your science. And success rates are very low. Typically 1 in 5 or 1 in 10 people who apply for a grant will get it. So if you want to be funded for your research, you may need to apply for multiple grants. So most senior researchers spend half or more of their time applying for funding in one way, shape or form, which is a huge time sink. But the grants, not only do you need it to allow your research to proceed, it depends a bit on what your research field is. If you're doing theoretical physics, maybe all you need is access to a computer and a piece of paper. If you're doing observational astronomy, you need access to big telescopes. If you're building a lab, you might need a lot of lab equipment, which will cost money. So if you don't get the grants, maybe your research stops, or you're forced to do some research you didn't particularly want to do because you haven't got the right equipment. But also, getting grants is seen as a proxy for how good a researcher you are. So to get promoted through those various stages, people will say, well, how many grants did you bring in? What's your grant success rate? What's your track record? Oh, we've brought in $1 million, we've brought in $4 million. Somebody who's brought in $10 million is more likely to get that permanent job because the university will like them. They bring money in.